Hello everyone, this presentation is about another benchmark that G3S recently sustained, and this benchmark is built out of only two formula files. One of them containing 20 million variables and 66 million clauses, and the other one 30 million variables and 100 million clauses. And if you watch the other videos, you will see that actually I raised the bar, because the largest I showed so far was with 10 million variables. Besides the raising the bar, what else is specific to this kind of formula? Well, first of all, the search space. The search space is so large. In this case, for instance, the search space is 10 to the over 6 million possibilities. So the solution can be found within the 10 to the over 6 million possibilities, whereas the other one is even larger, which is 10 to over 10 million. How large is that? Well, compared to the universe, which has only 10 to the 90 individual particles, like photons, electrons, protons, and neutrons estimated, when 10 to 10 million is unimaginable larger than that. However, this benchmark lasted for over 2 million seconds. As you can see, the first one started on the 16th of April and finished 8.5 days later, whereas the second one started immediately after and took around 16 days to finish. Now, what was the hardware I was using for that? Let's take a look at the machine. It's a one i7 CPU with 3.6 up to 4.9 gigahertz and 32 gig of RAM. So very minimalistic configuration, hardware configuration. The question is, what are those humongous search spaces used for? Is there any practical case? Is there any real world scenario where such a formula can be produced and used in order to solve something? And the answer is yes. There are a number of fields, many fields actually, where such a complexity is absolutely normal. As for instance, computational chemistry, like modeling and simulating complex chemical reactions, molecular dynamics, or explore potential energy surface. Or genome assembly, like solving complex, very complex puzzles, in fact, in genome sequencing, especially for organisms with large and complex genomes. Supply chain optimization can also produce such a formula, or quantum circuit compilation. And what else? Fluid dynamics, I can think of, cybersecurity, virtual reality, natural language processing. There are many fields where this kind of complexity can be encountered. And finding a solution for something like that is really, really hard, as you can imagine. However, G3S managed to figure out at least one solution within a reasonable time, I'd say, for the given configuration. And especially what's very important here is the order of execution complexity, which is, as you can see, under n square. And that is absolutely spectacular. Plus, I'm not so sure that there are engines out there capable of such a performance as G3S on this minimalistic hardware configuration. Or even more than that, I don't think there are set solvers engines out there able to deal with such a large solution space as these ones. I mentioned earlier about quantum computing. How about that? How about quantum computing solving something like that? Is this even possible, feasible? Well, at this point, certainly not. Why? Because in order to solve such a large formula, a quantum computer needs at least that many qubits. 30 million in this case. Whereas as per today, I think the largest has less than 1,000 qubits, and the road to 30 million is quite a long road. So not for now, and I'm not sure about the future, so I don't want to speculate. Now, another question would be, how many solutions? So, yeah, G3S found a solution, and here is one for the 20 million formula, and this is for the 30 million formula. How many solutions are there in that space? And I will keep this question open as a challenge for those who are interested in looking at this kind of complexity, and I can also make public this zip file, which actually contains the two CNF files plus the solutions themselves that G3S found. As a remark, and one more thing, I took a screenshot of the command line window that you were just looking at earlier, at this one. As a conclusion for this benchmark is that, in my mind, this is an historic leap forward, which is actually a monumental challenge for anyone. I can easily say that this kind of complexity not many algorithms can do, if any. Not even quantum, as I mentioned. And the implications of this is a breakthrough, actually, can be really far-reaching. Now, the next benchmark, I will raise the bar again with another 10 million variables, and I will try to solve that in the near future. And if you have any questions or you want to try it out to solve those formulae, send me an email, dan@q-dss.ro. Until then, stay safe and goodbye.